Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Khairul Azrin bin Asmanizam. My number metric 2024213436. I would like to start presentation with an introduction first. Actually, I would like to present project the ice shaver machine. The primary objective of this project is to significantly enhance existing ice shaving mechanism. We aim to achieve this by integrating a high efficiency electric motor and advanced safety features, making it suitable for both commercial and domestic application. Our development process was driven by data. We conducted a market analysis involving 90 respondents, and the feedback highlighted three critical pain points with current market models. First, excessive waiting times due to slow processing, physical fatigue caused by the manual operation, hygiene concern, specifically the issue of ice scattering during the shaving process. Based on the data, there is an overwhelming consensus supporting the innovation of a machine that is not only faster but also cleaner and more efficient. Moving on the design justification, why did we choose this specific configuration? We begin by performing a comparative analysis of existing products. We found that the traditional crank models are labor intensive and slow, while the belt type shavers often suffer from low power transmission and durability issues. To address this limitation, our project introduced a robust or firm solution. Our machine is powered by a 180 watt motor operating at 1450 rpm. This powerful setup allows for an impressive production rate of 65 kg of shaved ice per hour. Utilizing a precious stainless steel dual blade system. However, our key competitive advantage lies in its hybrid design. This machine operates automatically but retains a manual function, offering flexibility during power outages. This combination results in a product that is significantly more stable, durable, and ergonomically superior compared to existing solution. Thank you from me.
Hi, my name is Aidil Hakimi Mencik Nasaruddin, and my ID number for UiTM is 2024-25012. And I will be explaining about 3.0. There will be modifications and key features. So first we have safety shield, addition of transparent guard to the prevent ice splashing or protect hands from the moving parts. So basically, safety shield is where it's a shield that is covered for the base of the processing of the ice shaving. So basically, the blade is on the bottom and the safety shield is around the base of the moving parts. So it will protect the people surrounding it, and the splashing of the ice will be not going out of the base. Secondly is the drainage system, a dedicated channel for excess water to ensure the workspace remains dry. So if we work with ice, basically there will be water excess. So in order we want to keep the workspace dry, we have to put a drainage system so the parts will remain dry. Well, not that dry, but will remain from excess water, out of the excess water. So then we have the blade adjuster, a knob to determine the fineness of the ice according to menu requirements. So basically we have many requirements for the thing we'll be doing with the ice. So basically the blade adjuster will be can be adjusted. So if if we want the ice will be thinner or much more chunkier kind of state. So that is my part. Thank you.
Hi, Alia and my friend. Before I start, my name is Imran Ahmed Khan and Ahmed Khan and my lecture number is 2024228492. Okay, I will present about the component list from CAD part. This year we got 5 main components that I will present to you that are crucial to our part design and our mini project. So the first is it's base of the ice machine. The method that we use is sturdy aluminum. Why we use this? Because this material can support heavy load such as shaft, motor, and other things. Second is ice block platform. This this component is the area to face the ice block and its place to be used to shape the ice block. Next is shaft motor. These are the components that we added before from the previous design of ice machine where it does not have any shaft motor and we added it. So the next is shaving blade. We use stainless steel for this one because stainless steel is easier to maintain. It will not rust easy, so we can use it for a long term. Sorry. Next is flywheel. We still use flywheel, of course, because even though we have shaft and motor, it just need to run the machine. The flywheel is for us to control the rotation either we want to go up and down, also we want to go left and right, depends. And the last is safety shield. It is an additional safety component that we put it at the ice machine so that the not the debris, the extra ice that we apply when we use the ice machine will not be toward us because the small pieces of the ice machine is a bit sharp. So we put this safety shield so it will not hurt us when we operate the ice shaving machine. Thank you.
Hi and very good morning to our lecturer, IRTS Dr. Kauslia. So my name is Haris Haikal bin Faizal and my matrix number is 2024258628. So today I'm going to present about my part 5.0 which is finite element analysis or FEA. So the first one, static analysis, tested the durability of the base against a load of 412 and 2 Newton. Result indicate the material can withstand the load without failure. So the frequency analysis, conduct the prevent resonance or in bracket extreme vibration. So for the frequency safety factor FSF, achieve value of 80 and 1 base and 227 227 pillar. So for the I can conclude all the tests that the design is highly safe and of the FSF exceed the minimum limit of 2. So if you can see the report, it shows that the frequency analysis a very natural frequency compared to the operating frequency. With FSF of around 80, there are no resonance base for the there are no risks for the base that are dynamically safe. for the vertical for the column frequency test, the first natural frequency 84.9 Hz, which the well above the operating frequency. The very FSF value confirm the structure is extremely safe and resonance rates. In conclusion, I can conclude here. The FEA confirmed both the base and vertical column support are structurally safe, vibration free, and suitable for the long operation. So that's all from me. Thank you.
Hi, my name is Amirul Hakimi Viroslan, and my student ID which is 2024433838, and today I'm going to share you about completion in our mini project. So firstly, the project successfully integrates engineering elements, CAD or FEA, with market requirement. So in this topic, every bolt, plate and motor housing was modeled in 3D. It ensured perfect fitment tolerance before a single piece of metal is cut. FEA, which means finite element analysis. So the stress test, by using FEA, the team simulate how the machine handle physical loads like torque of the motor or the pressure against the ice block to ensure the frame won't bend or snap under the pressure. Second, the resulting machine is more efficient, safer, and more hygienic compared to existing models in the market. So I will explain about efficiency. For the existing market model, it often slow, high ice weight, and high energy consumption. So our machine, it optimizes blade angles and motor speed to produce more shaved ice per minute with less waste. Second, in safety, for existing market model, it exposes blades and feeding risk to lack of emergency stops. For our machine, it features enclosed cutting area or sensors that stop the motor if the lid is open. For hygiene, for the existing model, it hard to clean for dead zone where the bacteria grow and rust exists. For our machine, it use food grade materials and a clean in place design with no hidden crevices. So from pie chart, ice shaver machine engineering focus area. So we have 4 of all among of the pie chart. So firstly, CAD or FEA integration, which means in 30%, the core engineering work that validate the structural integrity and mechanical fit. For 25% of efficiency, optimize motor torque and blade geometry for faster output. For hygiene, 25%, selection of food grade materials and clean by design surfaces. For safety, in 20%, stress analysis and mechanical guards to prevent operator injury. So that's all from us and from me. Thank you very much.